This is Algebra Lesson 6-3, Solving Systems by Elimination. The elimination method is a method for solving a system of linear equations. The goal is to add or subtract equations to eliminate something, one of the variables, hopefully. Now, there's more than one way to solve a system of equations. Some systems are written in a way that makes eliminating a variable a good method to use. The easiest to use the elimination method when equations, it is easiest to use the elimination method when equations are in standard form, ax plus by equals c. When they're not in standard form, but you can write them in standard form easily and eliminate a variable, that would be the form that I would use to try to get to the answer. Let's look at solving a couple of equations by elimination. Here we have two problems. In this first problem, we have two equations, 6x minus 3y equals 3, and negative 6x plus 5y equals 3. Again, like I did in the last video, I am going to number my equations. My first equation is number 1, and my second equation is number 2. If I look at these two equations, if I were to add them together just the way they were, I would notice that 6x and negative 6x would go away because they're opposites. So if I just add these two equations together, I can eliminate x, which is the whole point of the elimination method, is to get rid of or eliminate a variable. So if I add these together, the x's cancel out. Negative 3y plus 5y is 2y, and 3 plus 3 is 6. So now I have 2y equals 6. Divide both sides by 2, and y equals 3. Now I can simply plug it into either equation and solve for y. Excuse me, solve for x. I already have y. So if I take this first equation and I have 6x minus 3 times 3 equals 3. So 6x minus 9 equals 3. Add 9. 6x equals 12. Divide by 6. And x equals 2. So my solution to this equation is 2, 3. And once again, we could check it just like we could the last time. If I checked it in the first equation, I would have 6 times 2 minus 3 times 3 is supposed to equal 3. Well, 12 minus 9 does indeed equal 3, so it fits in the first equation. In the second equation, I would have negative 6 times 2 plus 5 times 3 is supposed to equal 3. So I would have negative 12 plus 15 equals 3. That also checks. So it definitely checks. So my solution is 2, 3. Now, do you have to always check your solutions in your homework? No. Is it a good idea to do it? Yes. And it's an exceptionally good idea to do it, to check every equation, every solution when you have a quiz or a test. That way you're definitely know you're on the right track or not. If we look at problem number 2, again, we have two equations. I'll aptly number them 1 and 2. But if I look at these, I'm like, well, if I add them together, nothing goes away. But that means if I multiply one of my equations by something, I could get something to go away. And I'm looking at this going, well, if I take my second equation and multiply it by negative 1, then the 5x will go away. So I'm going to take this equation and I'm going to multiply by negative 1. So giving me a new equation. My new equation would be negative 5x minus 6y equals negative 34. My original first equation, 5x plus 3y equals 22, stands. So if I add these two together, I get negative 3y equals negative 12. Divide by negative 3, and y is equal to positive 4. And once again, I can plug it into either equation 1 or equation 2. I think I'll plug it into equation 1. So 5x plus 3 times 4 equals 22. So 5x plus 12 equals 22. Subtract 12 from both sides. 5x is going to equal 10. Divide by 5, and x is equal to 2. So my solution here would be 2, 4. Now, some teachers will teach you that you can just subtract the second equation from the first equation. But I find that all too often when I ask people to subtract, they forget to subtract everything and they only subtract the terms that cancel out, which is why I always teach it's better to multiply by a negative and then add the two equations together because you're less likely to mess up a sign somehow. Okay, now, what happens when you can't just multiply an equation by a negative and a variable cancels itself out? What do you do then? Well, that's when you can choose to multiply one and or both equations by something. If I look at problem number 3, my first equation is negative 6x plus 5y equals 4. And my second equation is 3x plus 4y equals 11. It's easier to eliminate a variable if one of them is negative and one of them is positive, because then you don't have to worry about multiplying by a negative. But it doesn't really matter. I could just choose to get rid of the y, or I could choose to get rid of the x. I'm looking at this and going, well, if I multiplied equation 2 by 2, that would eliminate my x. So I'm going to take equation 2 here, and I'm going to multiply it by 2, giving me a new equation. That gives me 6x plus 8y equals 22. And it's always good to show what you're doing to your equation so that me, the teacher, when I'm looking at your work, I can determine how did you get that equation. And maybe you meant to multiply by 2, but you multiplied one thing by 2, but another thing by 3. So it's awfully helpful if you show me what you're doing so that I can follow. Top equation, negative 6x plus 5y equals 4. Now if I add these together, the x's cancel out. 8 and 5 is 13, so 13y. 22 and 4 is 26. Divide both sides by 13, and y is equal to 2. Once I know what y is equal to, I can solve for x. I'm going to put it in the second equation because there are smaller numbers. So I have 3x plus 4 times 2 is equal to 8. So 3x plus 8 equals 8. Oops, 3x plus 4y equals 11, not 8. I don't know why I was thinking 8. This would equal 11. That's better. Subtract 8, and you get 3x equals 3. Divide by 3, and x equals 1. So my solution would be 1, 2. Now in problem 4 here, I can clearly see that I'm not going to be able to take one equation and multiply it by one thing and be able to add it to eliminate something. Because my first equation says that 6x plus 2y equals 4, and my second equation says that 10x plus 7y equals negative 8. I'm looking at this going, ooh, this is not so good. So I can either find a common denominator between 6 and 10, or I can find a common denominator between 2 and 7. I know that the common denominator between 2 and 7 is 14. So I'm looking at this equation going, okay, let's take the top equation and let's multiply it by 7. And let's take the bottom equation and let's multiply it by negative 2. Because I have to have a positive and a negative, and since everything in all the variables in both equations are positive, one of the equations has to be multiplied by a negative. It doesn't really matter which one. I could have multiplied the top equation by negative 7. All right, if I distribute that 7, 6 times 7 is 42, so I have 42x plus 14y equals 28. That's my new equation number 1. My new equation number 2, negative 2 times 10 is negative 20x minus 14y equals negative 2 times negative 8 is positive 16. Now, if I look at these two equations, now y's cancel out because I have a positive 14y and a negative 14y. So I take 42x, add negative 20x to that, and I'm going to get a positive 22x. 28 plus 16 is 44. Divide both sides by 22, and x will equal 2. Now that I know what x is, I can solve for y in either one of the two equations. I'm going to plug it back into equation 1. So I have 6 times 2 plus 2y equals 4. So 12 plus 2y equals 4. Subtract 12 from both sides, and you get 2y equals negative 8. So divide both sides by 2, and y equals negative 4. So my solution here would be 2, negative 4. As you can clearly see, the elimination method is quite handy. However, the numbers get bigger sometimes. So you need to be very careful with your multiplication when you're trying to get rid of a variable so that you can keep watching what will happen. Let's take a look at a couple more equations. Here we have 2x plus 12y equals negative 30 and 3x minus 4y equals 17. I'm looking at these two equations going, okie dokie. Equation 1, equation 2. I could either multiply both equation 1 and equation 2 by something to get rid of x, or I'm looking at this going, wow, and I could get rid of y by multiplying equation 2 by 3. I don't even have to multiply by a negative 3. I can just multiply it by positive 3. So I'm going to take equation 2 and I'm going to multiply it by 3. Equation 1 I'm going to leave the same, so I'm going to have negative 2x plus 12y equals negative 30. Equation 2, 3 times 3x is 9x, minus 12y equals 51. So now my y's have canceled out. Negative 2x plus 9x is positive 7x. Negative 30 plus 51 is 21. Divide by 7, and x is equal to 3. So I'm going to just choose equation 2, not my multiplied version, my original version. So I'm going to have 3 times 2 minus 4y equals 17. So 6 minus 4y equals negative 17. Subtract 6 from both sides. I get negative 4y equals, wow, terrible y. Negative 4y is going to equal, oh, I messed up. It would be helpful if I plugged that in properly. Let's start that over again. Back into equation 2. It's going to be 3 times 3. I don't know where my 2 came from. Minus 4y equals 17. So now I have 9 minus 4y equals 17. Subtract 9. Negative 4y is going to equal, let's see, positive 8. So divide by negative 4. Y is going to equal negative 2. There we go. So my solution here would be 3, negative 2. Always give your solution as a coordinate pair. Okie dokie. Looking at problem number 6. I'm giving a lot of examples because it's better to have too many examples than not enough examples. I need to get rid of either x or y. I don't think it matters which one I decide to do, so because both of them I'm going to have to multiply both equations. If I decide I want to get rid of x, I have to multiply the top equation, let's say the top equation by 3, and the bottom equation by negative 2, because the common denominator between 2 and 3 is 6. So my first equation becomes 6x minus 9y equals negative 36. My second equation becomes negative 6x plus 4y equals negative 4. So I end up with negative 5y equals negative 40. Divide by negative 5, and y is equal to positive 8. Let's see, let's plug it into equation 2, because equation 2 is smaller number, at least the constant. So 3x minus 2 times 8 is equal to 2. So 3x minus 16 equals 2. Add 16 to both sides. You get 3x equals 18. Divide both sides by 3, and x is equal to 6. So the solution of this equation is 6, 8. The more you do these, the better you will get at them. Just be careful to indicate what you're doing to each equation so that it's clear to the person who's trying to help you if you can't figure out the answer, what you were doing, how you got from point A to point B. Now, recall that if you get a false statement as you solve a system, then the system has no solution. And if you get an identity, then the system has infinitely many solutions. The same thing can happen when solving a system of equations using elimination. So we're going to take a look at a system and we're going to try to figure out how many solutions it has. So in problem number 7 here, we have the first equation, which is 12x minus 8y is equal to 20. And we have the second equation where 3x minus 2y is equal to 5. I'm going to try to get rid of, I think I'm going to get rid of x. So I'm going to multiply this by -4. So my first equation stays as 12x minus 8y equals 20. My second equation is going to be -12x plus 8y is going to equal -20. Well, what do you know? Absolutely everything canceled out. I have 0 equals 0, which is a true statement. This is definitely true. Since we get a true statement, this would have infinitely many solutions. Now, if we were graphing this, we would have to say on what line it has infinitely many solutions, but it just asked me how many solutions it has, so it has an infinite number of solutions. So that's all I need to put here. Now we can also do word problems, real life application problems. And the more we do them, the better you'll get at them. At first they seem a bit confusing and sometimes a little bit hard, but they actually are, I think, a little easier to solve with 2 equations than they are with 1 equation. Because before, I was always trying to get you to define one variable in terms of another variable. Now we can actually use 2 different variables. So let's look at this problem here. It says 4 times a certain number is 3 more than twice another number. The sum of the first number and twice the second number is 5. Find the numbers. Well, we're talking about a first number and a second number. So why don't I let x equal my first number? And let's let y equal my second number. So 4 times a certain number. Let's just make it 4 times the first number. So 4 times a certain number is means equals 3 more than twice another number. So twice the other number, and then 3 more than that. So that's my first equation. Okay. And then the sum, which means added together, of the first number, sum of the first number and twice the second number is 5. That's my second equation. Now these are not written in a form where using elimination would be nice. So I need to write them in a form where using elimination would be nice. So I need to rewrite equation 1 in standard form. So it becomes 4x minus 2y equals 3. ax plus by equals c. Second equation is written in the right form. So x plus 2y equals 5. And now I can look at it and say, wow, look, since I rewrote these in standard form, my y's cancel out. So I now have 5x equals 8. And you're like, ugh, I get a fraction. That's okay. Sometimes you can get fractions. Fractional answers are reasonable answers at times. In this case, yes. Divide by 5. So x is equal to 8/5. I would not change this to a mixed number, because if you change it to a mixed number, you're going to have to put it back into an improper fraction to solve the equation. So I am now going to look at, let's see, where do I want to put it into? It really doesn't matter which equation I decide to put it into. I'm going to put it into equation number 2. So x is 8/5. So I have 8/5 plus 2y equals 5. Subtract 8/5. So 2y is going to equal, now think about this. This has got 5/1, so it would be the same thing as saying 25/5. 25 minus 8. Right? 25 minus 8 is 17. Now I need to solve for y. I normally would divide by 2. Dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply by 1/2 because I have a fraction on the right-hand side. So all of these cancel out, leaving me with y is equal to 17 tenths. So the numbers are, since this is a word problem, we have to write it in a complete sentence. The numbers are, and we can leave them as improper fractions, that's perfectly fine. 8/5 and 17 tenths. Or you could have said the first number is 8/5 and the second number is 17 tenths. Let's do one more word problem. A concession stand sold a total of 138 small and large popcorns. A small popcorn cost $2.50 and a large popcorn cost $4. Total popcorn sales were $466.50. How many large popcorns were sold? Well, since it's talking about large and small, I'm probably going to use both variables here. So I'm going to let x equal a small, and I'm going to let y equal a large. And it could be vice versa, it really doesn't matter. Just so you know which one is which, so when you finish solving for your variable, you know which one you solved for. All right, so they sold a total of 138 popcorns. So the number of small popcorns plus the number of large popcorns has to equal 138. All right, so number of small popcorns is x, plus the number of large popcorns is y, and that has to equal the total of 138. That's my first equation. My first equation talks totally about how many popcorns that I sold. The second equation is going to talk completely about money. Okay, the cost of a small popcorn is $2.50, and the cost of a large popcorn is $5. So every small popcorn I sell, I have to multiply by $2.50, and every large popcorn I sell, I have to multiply by 4, and that's going to give me my total amount of money that I made, which was $466.50. There's my second equation. Now these numbers are fairly large. Okay, so it's a higher likelihood you can make a small mistake somewhere, so be very careful here. I am going to take equation 1 and I'm going to multiply it by 4. I'm going to rewrite it down here so that I have enough space. So that gives me 4x plus 4y. It's going to equal 138 times 4. Oops, I should multiply by -4. Nothing's going to cancel out. Let's back that up. Because I just realized that. I'm like, well, that's not going to help me at all. I'm going to have 8y, not -8y. So -4x minus 4y. And 138 times -4 is going to be -552. Equation number 2 here is going to be just like it says, 2.50x plus 4y equals $466.50. And here's where having your calculator would be handy, so you don't have to deal with all the lovely decimals and make a mistake because you were trying to do too much in your head and messed it up. So -4 plus 250 is -150. -4y and positive 4y, excuse me, cancel out. -552 plus 466.50 is -85.50. So I get -1.5x equals -80.5.5, which is perfectly fine because if I divide by a negative, the negative signs cancel out. So if I divide by -1.5, -85.50 divided by -1.5 is 57. Okay. Now I'm going to take equation 1, the original equation 1, which says x, which is 57, plus y, which I don't know, equals 138. So subtract 57 from both sides. and y will equal 81. Okay, since it is a word problem, we would say they sold 57 small popcorns and 81 large popcorns. Now I know it didn't ask me for how many small popcorns, but it never hurts to write them both down because then you'll definitely get the one they want. Okay, so they sold 57 small and 81 large popcorns. All right, closure question for today. What kind of coefficients of x or y are needed to solve a system by adding equations? What kind of coefficients? That means the numbers in front of x and y. In one equation, they have to be what? And then in the second equation, they have to be what? That's basically what I'm looking for. What kind of coefficients of x and y are needed to solve a system by adding